Bonjour anybody's, welcome back to another video. Today's first question is, in the diagram below, three segments intersect at O and line OD divides the angle COE into equal angles. The ratio of angle COB to angle BOF is 72. 7 to 2, not 72. What is the number of degrees in angle COD? How would 72 even work? Anyway, not the point. So, this might look a bit impossible at first because it's like, oh my god, they only give us two numbers, and what the heck am I even supposed to do with those two numbers? They're stupid and in ratio. But don't panic, okay? So if OD divides COE into equal angles, but since these guys are on each side of the line, this means that this and this are also equivalent. And you might be like, oh, cool. So, but the difference that it makes here is that if we just solve for BOF and divide by 2, it would also be equivalent to our angle that we're looking for, COD. And since BOF is already in our ratio here, it'll make it a bit easier for us to solve for it. And as you can see, COB and BOF both combined make a 180-degree angle. Therefore, they are supplementary. So we can actually put this ratio to use, and since it's 7 to 2, that means that in total there are 9 parts. BOF, which is the number we're looking for, takes up 2 of those 9 parts. And 1/9 of 180 is 20. 2/9 of 180 is therefore, 2/9 of 180 is then equivalent to 40. However, we didn't even need to solve that far, because since we need half of this anyway, this means that our answer is 20 for COD, because we split it in 2. Yay. Moving on to problem number 2. In the diagram below, line BM divides angle ABC into 2 angles with the same measure. BP and BQ divide angle ABC into 3 angles with the same measure. If angle MBQ is equivalent to 28, then what is angle CBP? So, think about it this way, okay? Since we don't necessarily know just based off of the diagram, so this seems pretty simple, right? We just need CBP, which is like this angle, and since it's already given you this many terms, you should already know, right? No, but we don't necessarily know that MBP and MBQ are equivalent, although there is a way to prove it. So, if, which the problem already gives us the terms for, since CBM and ABM are equivalent because BM divides it into 2 angles with the same measure, yada yada yada, we can also confirm that since BP and BQ divide ABC into 3 angles with the same measure as well, this is 1 angle with the same measure, this is the second, and this is the third. Therefore, angle CBM is equivalent to angle ABM, which is also therefore, because of the other term given by the problem, ABP is equivalent to angle CBQ. And since it has also been divided into these 2 parts and we know this means that since this and this both have one of these, this means that angle ABP plus angle PBM, since it's equivalent because it's split into 2 equivalent angles, CBQ plus angle QBM. And since, as we proved in the second little bit, that ABP and CBQ are equivalent, angle PBM is equivalent to angle QBM. And it's just nice to have some reassurance, okay? So now we know that these 2 center little angles are equivalent, and solving from there is basically smooth sailing. If MBQ is equivalent to 28, that means that PBM is also equivalent to 28. So since we're looking for CBP, like so, we just need this center bit, which adds up to 56 because there's two 28s, and this little bit is also 56 because they are in 3 angles with the same measure. Therefore, 56 plus 56 is 112. So yeah, that's the end of this video. I hope you guys enjoyed, and I hope you guys learned something new, and I will see you all on the next one. Bye-bye!